What exactly is a DVWA? DVWA stands for Then Vulnerable Web Application. This is internationally insecure PHP or MySQL web application designed to help developers, cybersecurity, and penetration testers to learn and practice web security in a controlled environment. In this video, we will show you a cross-site scripting attack demonstration. Cross-site scripting actually a web security vulnerability that allows attackers to inject malicious script into a web page viewed by others. There are three main types of XSS, which are DOM-based XSS, reflected XSS, and store XSS. Each type of XSS vulnerability involves the injection of malicious script into a web page, but they differ in how and where the malicious script is injected, executed, and stored. For this video, we only focus on two types, which are store XSS and DOM XSS. Here is the comparison of both of them. For the first demonstration of the cross-site scripting attack is stored cross-site scripting attack. This store XSS only occurs when the attacker submits a malicious payload via a form or input field. The malicious script is persistently stored on the server and then served to any user who accesses the affected page. Once it's stored, the script will execute automatically every time the page is accessed by any user, making it a persistent vulnerability. First thing first, we need to make sure that DVWA at the low security level. Then we navigate to the cross-site scripting store. Now we can try to enter any word in name and message field to see how it works. In normal page, it will produce output like this, but now we would like to exploit the vulnerabilities. Let's see the page sources, whether our unit string is reflecting or not. Since both are reflecting in the browser, so both this field may be vulnerable to store XSS attack. So let's input a name of our choice into this designated field. And then for the message field, we will enter this basic payload. When we submit, this alert box will appear, indicate that vulnerability of the site to store XSS attacks. That's for lower level. Now let's try the cross-site scripting store attack at the medium security level. First thing first, we need to make sure that DVWA at the medium security level. Then we navigate back to the cross-site scripting store. And when we try to re-entering the previous input and previous payload, we can see that no pop-up is triggered. This could be happen to various reasons, like a security measure be implemented on this web page. So let's see the view sources. Here, we can see that the first block, it performed the input sanitization on the message field. This block contains two PHP functions, which are strip tag that help to remove all HTML tags from the message field before storing them in the database. The second one is HTML special char. This helps to convert all the bad character and their equivalent HTML character encoding so they won't remain in their original form when they reflect back in the browser. The second block, it performs input sanitization on the name field. The function str replace actually can replace all the occurrence of the script with null and blank. This function is case sensitive, so we can just change one out of many words of the script tag to the opposite of this. Here they use lowercase, so our payload can use uppercase. Let's try to inject this payload. Unfortunately, no changes happen. So let's try to enter the payload on the name field. But it does not accept all the characters of our payload. So let's us inspect the name field. Here we can see there is some restriction on the maximum length. We can just change the numbers to the numbers that more than the numbers of character in our payload. Now we will receive a pop-up alert, thus confirming that we success to exploit this vulnerability at the medium security level. Now let's try cross-site scripting store attack at a high level security. First thing first, we need to make sure that DVWA at high level security. And then we can navigate back to the cross-site scripting store. And if we try to re-entering a previous input, we can see there is no pop-up triggered, meaning that this new web page actually implement a new security measure. Now let's us see the source. Other than the field has been sanitized to exclude a special character, it also has a function of pre-replace. This function pre-replace actually replace every occurrence of the script tag irrespective of their cases with null or blank, meaning that whether the script have a lowercase or uppercase, they will be removed, they will be sanitized. So let's try to input a payload that do not have any script tag. We can see there is a pop-up. This shows that we successfully to exploit the vulnerability at the high security level. Yes. For the second demonstration is the DOM-based cross-site scripting. This DOM-based XSS actually only occurs when the attackers send a malicious payload via URL parameters or other client-side input. This attack is executed by modifying the document object model of the page. The malicious script is not processed on the server, but rather in the browser, where JavaScript running on the page use unsafe data from the URL or user input to modify the DOM. It's called DOM-based because the attack exploits the client-side DOM, which is manipulated by JavaScript. First thing first, we need to make sure that this DVWA at a low security level. And then we can navigate back to the cross-site scripting DOM. Here you can see that we need to choose a language, but before that we need to take note of this URL. The reason is because the DOM-based cross-site scripting attack can happen through URL. Now let's choose any language. The result shows that at the end of the URL, the value that we choose or the language that we choose appear at the end of the URL too. It seems that this value and this value interconnected to each other. Now let's prove our theory by typing any word at the end of the URL. This shows that the value that I put also appear at the drop-down menu. Now let's try to inspect this base source. This document.location.href.substring actually is our potential source because it accepts the user input inside the default parameter. While this document.write actually our potential sink because it reflects the enter value from sources inside the option tag. This indicates that whatever we put in URL actually will appear on the web page. Let's try to put a basic payload at the end of this URL. When we press enter, we will get a pop-up. This shows that we successfully to exploit the vulnerability of this web page. Now I would like to get a cookies from the web page. We can use this payload. The result shows that we successfully to retrieve the cookies of this web page. So that's how we exploit the uh, this web page at the low security level. The first thing we need to do is to make sure that this DVWA at the medium. The first thing we need to do is to make sure that this DVWA at the medium security level. Next, let's navigate back to the DOM cross-site scripting. Let's try to put our previous payload at the end of this URL. It seems there's no pop-up triggered, which means that we can't use our basic payload. We have to modify the payload manually, but before that, let's analyze the sources page. Through this page, we can see that they use strippost function, where they block our script tag while the location indicate that it will redirect user to the default language. That's why even we put our basic payload here, it still redirect us to the default language, which is English. To overcome this restriction, we can do by breaking the DOM. For this, we can use a closing select HTML tag. Let's try to put this new payload in at the end of the URL. The pop-up shows that we successfully to exploit the vulnerability of this web page. Let's proceed with the DOM-based cross-site scripting attack at higher level. First thing first, we need to make sure that this DVWA at the higher security level. Next, we navigate back to the cross-site scripting DOM. We try to enter like usual. No changes happen. And how about our previous payload? No pop-up triggered, meaning that this web page actually implement a new security measure. Let's view the source. Based on this, the provided PHP code actually implement a whitelist filter. This whitelist filter helps to restrict the default parameter to only a few specific value. Therefore, when the user's input does not match with one of these value, it will redirect us to the default value. To overcome this restriction, actually we can use a logical AND with the closing select tag. This logical AND actually help the value treated as a valid, while the closing select tag actually help to break the DOM. Let's try to enter this new payload at the end of our URL. This pop-up confirms that we have successfully executed the payload. And for your information, this payload actually will remain as a part of HTML DOM. This includes at the low security level and at the medium security level too. And that's all from me. And that's all for our demonstration. And that's all for the cross-site scripting attack demonstration. In conclusion, both of these demonstrations highlight the importance of implementing comprehensive server-side and client-side input validation and adopting a defense-in-depth approach combining multiple layers of sanitization and encoding. Therefore, regular testing application for vulnerabilities using tools and techniques similar to those are very important to make sure that the web page is very secure for user to use.